Hello everyone. So your lesson for today is confidence interval, and we're also going to discuss about margin of errors. So first, confidence interval refers to the probability that a population parameter will fall between a set of values for a certain proportion of times. And it measures the degree of uncertainty or uncertainty, in common being 95% or 99% confidence. So the confidence interval, for the confidence interval, we want our confidence interval to be low. Uh, we want our interval to be short, in other words. So for example, at 95% level of confidence, I am sure that the mean value falls between 98 to 100. We prefer a shorter length of confidence interval rather than when we say 1 to 100. So this doesn't tell us anything. So too long or too long lang kaya iyang length of confidence interval. But when our length of confidence interval is short, we know that the possible value for will fall between 98 to 100. So uh, the formula for the length of confidence interval is given by the length of confidence interval length of confidence interval. This is the upper central limit and the lower central limit. Okay, so for example, find the length of the confidence interval. So of p greater than 0.275 and less than 0.360. So you can easily find the LCI for this by subtracting the upper central limit, which is 0.360 minus 0.275, and this should give you 0.085. So it tells us that the length of confidence interval is from 0.275 to 0.360 is only 0.085. Therefore, the length of confidence interval is 0.085. Now, what if you are given a problem that um, the upper and lower central limits are not given? So what if ang problem kay wala kay upper central limit and lower central limit? How can you solve for the length of confidence interval? So okay. Note that the formula for that interval estimate of population mean mu with the known variance sigma squared is this. Mu is greater than x sub bar minus z sub alpha over 2 times z over square root of n. And it's less than this value again. So the LCI formula now is this: 2 times z sub alpha over 2 times sigma over square root of n. So note that if n is greater than or equal to 30, we should use the value z. Therefore, we use the z table. If otherwise, n is less than 30, it is t distributed, when we should use the t table, and we assume that it follows a t distribution. Okay, so here in example 2, find the length of the confidence interval given the following data. So we have the following standard deviation. This is a population standard deviation, since it's sigma equal to 0.30, n is greater than 70, and the confidence level is 95%. So note that since this is greater than or equal to this is greater than 30, we should follow a z the normal distribution, or we should use the z table or z value. So for step 1, we should find the value of alpha. So actually the confidence level is equal to 1 minus alpha times 100%. Then since it's given, 95% equal to 1 minus alpha times 100%. To cancel 100%, we divide both sides by it. So cancel. We have 0.95 equal to 1 minus alpha. And transpose, we have alpha equal to 1 minus 0.95. Therefore, our alpha is 0.05. Now, on step 2, since this problem doesn't give us the upper and lower central limits, our LCI can be taken by 2 times z sub alpha over 2 times sigma over square root of n. So we should get this value. So alpha over 2 is equal to 0.05 divided by 2, which is 0.025. Therefore, z sub alpha over 2 is equal to z 0.05 over 2, which is z is 0.025. Now, if you can recall from our table 1, the standard normal values or the z scores, we have this as our center or mean, and every half is actually equal to 0.50, right? And this whole probability, this whole area here is equal to 1. If we're using table 1, we should know that 0.50, we subtract this value, let's say 0.50 or 0.500 minus 0.025 is equal to 0.475. Now let's look at what we have here. Table 1. So here we have z sub 0.475. The equivalence for this is this one. Therefore, we have z alpha over 2 is actually equal to what? Let's look for 0.475. So 0.475, or its closest value, is this one. This is exactly 0.4750. So this is 1.96. Okay, so this is actually 1.96. So step 3, we solve for the LCI. LCI is equal to 2 times 1.96 times 0.30 or 0.3 square root of 70. This is what? 0.1406. And our conclusion would be, therefore, the length of confidence interval is 0.106. Okay. Now, for example 3, find the length of the confidence interval given the following data. We have S, this is our sample standard deviation, equal to 6.5. Our N is equal to 15, and our confidence level is equal to 99. So notice that N here is less than what? Less than 30. Therefore, it is T distributed, or we should use the T table. So to solve for the LCI, we have step 1 again. Same previously. From example 2, we have CL, which is 1 minus alpha times 100%. Our CL is already given, which is 99%. 99%. So 1 minus alpha times 100%. Then divide both sides by 100%. Cancel. So we have 0.99 equal to 1 minus alpha. If we transpose it, we have 1 minus 0.99 or 0.01. Alpha is equal to 0.01. For step 2, we get the degrees of freedom, which is n minus 1. This is the degrees of freedom. V is equal to n minus 1. V is what? 15 minus 1, which is 14. Then, instead of using the z, we have what? LCI is equal to 2 times t sub alpha over 2 times s over sigma n squared. Sigma over s over square root of n. And alpha over 2 is 0.01 divided by 2. We have 0.005. Right, so t sub alpha over 2 is equal to t 0.01 over 2, and this is t sub 0.005. Okay, so in our table, t 0.0 sub 0.05 and comma v, which is v is 14. Check out table 3, the t table. We have t 0.05 here, and our v is 14. So the answer here for t sub 0.05 with degrees of freedom 14 is 2.977. Therefore, this is this is what? 2.977. Step 3, LCI. We solve for the LCI. 2 times 2.977 times 6.5 over square root of 15. This is what? 9.99. Therefore, the length of confidence interval is 9.99. So class, I want you to understand that the higher your n value, the lower your length of confidence interval. And we always want the lowest length of confidence interval. Right? So in Bisaya, kung patason nimo ang imuhang number of n, ang imuhang length of confidence interval kay magka-narrow, and that's what we want. So in statistics, when you gather your data, you want to have as many as samples as possible. Okay, so standard value for n is 30. So if makaabot kag 30 man lang, it's appropriate to use the z table instead of the t table. Okay, so if you compare, this is the result for the t table, 9.99. But when you use the z table, when n is greater than 30, greater than or equal to 30, you have a very low LCI, and that's what we want. Okay, so this is an exercise, but you can do this on your own. Instead of getting a 1/2 crosswise paper, you can practice on your notebook instead. Okay, so I think that's it. Okay, for the second part of this video, we have deriving the formula for a sample size. So it means that if you have let's say we have Palawan, the island of Palawan, and there are let's say 68,000 people in Palawan, right? We have 68 local residents. It's nearly impossible to get the responses of all the 68,000. So the question here is, from 68,000, what is the valid n samples from this population? What is the valid n to represent this whole island? So unsa dapat akong n, ma'am? If 68,000 ang akong population, akong capital N, what should be my n? So this lesson you will learn that in this lesson. So deriving the formula for a sample size. So there are two things to remember when we decide on the quality of the sample size that we need. First is the confidence, and two is the narrowness of the interval. So if the confidence interval is relatively narrow, let's say narrow, let's say 0.70 to 0.80, narrow na ni siya, for example, and yung LCI here is 0.10, right? Upper limit minus lower limit, and you will know that the effect size is known precisely. So precise kay siya. Okay, imong possible values will fall between 0.70 and 0.80. But what if, let's say, you have a wider interval, let's say 0.60 to what? This is 0.93. So you will ask yourself, the uncertainty here is greater, right? The uncertainty here is greater, although there may still be enough precision to make decisions about the utility of the intervention, but daghan ki siya og possible values, right? So again, what I've said before, we want our length of confidence interval to be narrow, and we should have as low as a low LCI. So the computing formula in determining the sample size is derived from the formula of the margin of error. So I'll introduce another formula here. Margin of error. Let's say we have a margin of error. Gikan daw aning margin of error kay masolve da nato ang n. So the margin of error is equal to z sub alpha over 2 times sigma over square root of n. This looks familiar, right? So this is what the margin of error. So from here, um, we manipulate this formula to get the n. Okay? So, unsaon na to, we can get the n from this formula, margin of error. So, to solve, we have, I'm going to write this again, e equals z sub alpha over 2 times square root of n. So, you just need your knowledge in algebra, your basic algebra. So the denominator here in this side, right side, is square root of n. So to get rid of square root of n, we multiply both sides by square root of n. Square root of n. So cancel na ni cancel. So we have square root of n times e equals z sub alpha over 2 times sigma. Okay? So, di ba, atong goal is to get the formula for n. So, we should, our goal here is to have n equals to something. And we're doing this here. Okay? So, in this side, we need to get rid of e. So, we divide both sides by e and then cancel it again. So, we have square root of n equal to z sub alpha over 2 sigma over e. And to get rid of the square root here, we square both sides. So if you remember, you should remember this. Square root of n is actually equal to n to the 1/2. And if we square this, this is times 2. And by law of exponent, we have n 1/2 times 2, which is equal to n 2 over 2, or n is equal to 1. So we have successfully removed the square root here, and we have n equal to square root of no, not square root, z alpha over 2 sigma over e over 2. Therefore, our final formula here is n equals z alpha over 2 sigma over e squared. So, remember class, this is our formula for the sample size. Sample size formula. Okay? So what if we have a problem here? I'm not going to write the whole problem, but I'll get to the givens directly. So this is example 4. So your confidence level is 99%. Your E is what? 0.06. And your N is 0.5. So to solve, we should first start with the alpha. Step 1, solve for the alpha. We have CL is equal to 1 minus alpha over, oh no, times 100%. And CL is 99% equal to 1 minus alpha times 100% divided by percent divided by 100%. We now have 0.99 equal to 1 minus alpha. To transpose, we have alpha equals 1 minus 0.99, which is what? 0.01. Okay? I'm sorry, class. I'm sorry. I made a mistake here. This is not n. The n is 2. There's no n that is 1/2. Wala n nga 0.5. This is actually what? This is actually sigma, the standard deviation. So there are problems nagdili given ang n. Okay? Okay, mo man ni may solve. You will solve for n here in example 4. So the n is not given. So let's go back. Step 2. Step 2, we need to calculate alpha over 2, which is 0.01 over 2, and that is 0.005. And we assume here that it is normally distributed. We subtract this by 0.50 or 0.5 minus 0.005, which is equal to 0.495. Therefore, z alpha sub 2 is equal to what? Let's go back to our table. Table 1, 0.495. 0.495. Okay, somewhere around here. 495. So I think this one is the closest one. Okay. So that is 2.54. Right? 2.5 and 4. So 0.04. So that is 2.54. Then step 3, the formula for n that we derived was z alpha sub 2 times sigma over e squared. Therefore, we have 2.54 times 0.5 over 0.06. So I haven't solved this one yet. I'll use my calculator. This is 2.54 times 0.5 equal to divided by 0.6, 1167. So you have, oh sorry, my mistake. Should be what? 2.54 times 0.5. 0.5 divided by 0.06, 21.1667. Therefore, we have 21.1667. So if we round this off, we should have 21. N should be equal to 21. But no, sorry. This is, kulang pa ni siya squared, guys. Sorry kayo. Remember, not kulang pa siya na squared. I was, no, sleepy. So let's calculate that again. Let's say 21.1667 times 21.1667. Kaya squared man siya. So we have 448. We should have a whole value for this. Instead of 4484, pila to answer? 448.029 our n should be 448, and that's how we solve for n. Okay, so should do this one. Hello? Okay. So you should do this one in your in a 1/2 crosswise. Yeah, in a 1/2 crosswise. And when we get back on Thursday, on April 11, we will have a quiz. Okay? So do this one as an assignment. So here we have Christine wants to replicate a certain study where the lowest observed value is 10.4 while the highest is 12.8. So she wants to estimate the population mean mu within an error of 0.05 of its true value. Using 98% confidence level, find the sample size and that she needs. So I'll help you start plotting the given here. So the CL is what? 98%. The E, or margin of error, is what? The margin of error is given 0.05. Right? This is the margin of error. Zero five. Then what? The standard deviation. The standard deviation can be taken by it should be what? Okay. R over 4 for this case, where the range here is maximum minus minimum. since this is new, where the lowest observed value is 10.4 while the highest is 12.8. So you need to get the measure of dispersion. If you remember the IQR, the range, and the variance in the standard deviation. So this is another way of getting the standard deviation, guys. Okay, we have the range 12.8 minus the minimum 10.4, and this is uh, 2.4. Excuse me. Therefore, our standard deviation is 2.4 divided by 4. We have 0.6. Correct? So, yeah, this is the given. The confidence level, the margin of error, and this one, the standard deviation. So, solve for n. Don't forget to formulate a conclusion. It should start with therefore Christine needs a sample size of what you're looking for, and okay. So I hope that you somehow grasp the idea of margin of error. So that's it. See you on Thursday. Goodbye, everyone.